Good morning. It's my pleasure to be here. Today we are going to speak about the new gold standard in fake IOLs, mostly dedicated to ICL sizing. I'm Roger Zaldivar, head of the Instituto Zaldivar in Mendoza, Argentina. I have no financial disclosures. So I think that the pandemic, this incredible crisis that we have all struggled, has left a message. There is always a good time to reinvent ourselves, and definitely I can see in my patients that they have a different mindset today when we speak about surgeries. This is a new opportunity to make them get on board with different procedures, and of course fake IOLs are among those very interesting procedures nowadays. So as I was saying, every crisis is an opportunity, and regarding the fake industry, we have seen an incredible grown in the last couple of years. I always remember many years ago when my father was fully immersed in this technology. The price of the stock. Look at what has happened with the most important company in the world, that is Star. So their stock has grown from around 23 years ago to 100. It had a peak of 162. This means what's happening in the world, and everyone now is looking at fake IOLs like something really sexy, and a lot has to be with the safety profile, the overall safety profile with the lens, as was shown in this latest review done by Mark Packer. We've seen that this theory that changing the flow through the central aperture would definitely change the performance of the lens relating to cataracts and different problems that we experienced in the past. And results are true. Now we are very close to zero cataract formation, so which means that we can play a little safer with the lens closer to the crystalline lens. Of course, this is outside the US, where the B4C is approved. Here in US, hopefully you will have it soon, but this is important to highlight. So, but the story is not like this. The story is quite longer than what you know. So in 1994, my father, Roberto, together with Fengo, designed this first central flow in the lens, the effective lens. Here you have a true picture and a video of what was the first design. You can see that these fake IOLs didn't have the feet, but you can perfectly see the hole in the middle that was exactly the same size as the one that you have today, 316 microns, exactly the same. You want to see something cool? This is the surgery in 1994 of the first lens implanted inside the eye with the V4C back in those days. But the nice story is that this patient, let me show you, because this is true history. It took us many months to find actually this video. So you can see the technique was quite different. We didn't have a true injector or anything. And look, that's the lens inside the eye. But the interesting point was that the patent was issued in 1995 and already included the hole in the middle, to show you that this is not something new. This has been there for many years, and it was relaunched back in 2011. But good news for all of us is that, for example, this patient has around 25 years and still doesn't have a cataract. So the good news is that it's true that the performance is different. However, not having a cataract doesn't mean that you're going to be safe without a clear sizing methodology. And this is by far the only weakness that we can highlight today in the whole procedure. Sizing hasn't still been solved, despite we have good results. We have a very nice procedure. There is some room to space in sizing. So this hasn't been avoided, and this is what we really have to emphasize and focus. The worst complication that we can experience today as surgeons is having an angle closure glaucoma in a young patient. This can lead us to severe problems back in the nerve, and we can have anatomic pupil. So this is what we want to avoid, and more in a patient that is experiencing an elective procedure and at that age. So the question that we have to make is there a way to predict something that we have been trying forever. Well, there are two very famous predicting bold formulas, both from Japan, Nakamura and Akihito, and they're both based in anterior chamber measurements, mainly in angle to angle. So we did a comparison in 22 eyes of 25 patients, and we measured exactly this 24 hours post-op, comparing exactly the predicted bulb of these two formulas. Let's see the results. So, for example, here we have the real bulb achieved in blue. This is exactly what happened next day. And this is the prediction bulb by Nakamura. You can tell that despite it might have a moderate correlation, there is a large number of scatter in the results. So, for example, this one, we have more than 500 microns of scatter. So they are not truly predicting in a very sophisticated way. And if we check Akihito, another one, look, we have a large scatter between them. So this is the mean prediction error, which is very acceptable, but when you see the range and the standard deviation, they are just unacceptable. So my take-home message in this topic is it's really difficult to predict bulb with anterior chamber measurement. You can do better than perhaps Y2Y, and we'll see some results, but it's very difficult to really be where we want to be, to have a universal and straightforward procedure. So this is the weak correlation between ciliary valley, sulcus to sulcus, angle to angle, and Y2Y. You can see that there's not such a strong correlation. You see, there's a very big variability between them. So then, if we measure the sulcus to sulcus prediction, as we have been doing for last couple of years, are we going to have better results? Well, let's see what happens. So this meta-analysis carried on by Mark Packer showed that there wasn't really statistically significant difference in the achieved bulb comparing white to white and sulcus to sulcus. So where's the problem? Where are we failing? So the mistake is actually in the position. Look at this. This is a beautiful image of high frequency ultrasound, high resolution, carried on by ASCRS, where you can see the ICL and you can see a position here below the ciliary body, and here we have the other one below the ciliary body. So this is one position. Then we have another position, a below position that is, we have one under the ciliary body, as you can see here, and then we have an asymmetric position over the ciliary body at the sulcus. Then we have another available position that is both feet in the sulcus. So far we have three positions. This is another one showing how beautiful you can see with high resolution, this perfectly under the iris in the sulcus. And